Hello, boys and girls. Mrs. Steve Math TV here. Fido Day 33, Thursday, May 7th. Yesterday, we talked about a triangle's first name. Every triangle has a first name and a last name. Yesterday, we talked about the first name, which is either scalene, isosceles, or equilateral. Today, we're talking about a triangle's last name. And just like yesterday, I showed you a really important key concept chart on page 915. This is a very important key concept chart that's on 916 in your book. So if you don't have your book open to 916, pause the video and open your book. And what we're looking at here is we're looking at three different types of names for last names for triangles. Just like we had equilateral, scalene, and isosceles, those are the first name choices. The last name choice is acute, right, and obtuse. So you could have an equilateral, acute triangle, meaning that its first name is equilateral, its second name is acute. And that happens a lot, actually. Okay? Let's take a look at what these last names mean. So if the last name is acute, that means it has three acute angles. That means it has three corners that look very much like the letter V. See those three corners? See how those each look like the letter V? Yes, I know this one's upside down and these ones are on their sides, but they still look like the letter V. And I'm going to put three acute angles, and underneath I'm going to put the letter V to remind me that the letter V is the angles that look like acute, that are acute. So why don't you mark that down in your book too? Right triangle. In order for a triangle's last name to be right, R-I-G-H-T, it has to have one 90-degree angle. And it will only ever have one. It will never have two. So remember I told you right angles look like the letter L. Sometimes they're flipped upside down, but it has one right angle. As soon as you see a triangle with one right angle, you know its last name is right, R-I-G-H-T. And the last one that we look at is obtuse. If its last name is obtuse, that means it has one angle that is kind of wide. Remember I said it's like the hang loose. It has one angle that's wider than a 90-degree angle. Okay, it's kind of spread out more is a good way to put it. If it has one angle that's kind of spread out more, then you know its last name should be obtuse. So let's look at example 2, which is right up above. It's this pyramid. The first thing we want to look at is how many angles do you see? Well, you should see 3. You should see one here, and one here. And do you see any angles that look like the letter V? This one definitely, to me, see this corner? It looks like the letter V. And so does this one. Okay, see how those both look like the letter V? If you turn your book especially, or I'm just going to turn my phone. See? V and V. Now the top one, it could be an acute angle again. It could be a right angle, or it could be obtuse. Let's talk about, does it look like a perfect letter L? To me, it does not. To me, it looks like it would need to be like over here in order for it to be the letter L. Do you see that? I mean, granted, it would be upside down, but still. And you can always turn your book. And we can try turning our book. And look at this letter. It does not look like the letter L. It looks like it's less than 90 degrees. If it's less than 90 degrees, boys and girls, that would mean that all three of these angles are acute. And to me, looking at it, all three of them look like the letter V. Granted, this one here and that one there are skinnier V's than this one. But this isn't even to 90 degrees, so I know it's acute. So answering the first question, how many angles of the triangle are acute? 3. We know triangles only have 3. So if all 3 of them are acute, 0 of them can be obtuse, and 0 of them can be right. Looking down here again, 3 acute angles. That pyramid shows an acute triangle. I know I didn't take out my ruler, but if I'm looking at this, just from looking at this, I think it probably has 2 sides that are exactly the same length, which would also make it isosceles. So if we were gonna put a first name on this, we would call it isosceles acute triangle. So the first name would have been isosceles, the last name is acute, and it's a triangle. Let's take a look down here at number 2 on page 916. We're gonna classify it again based on its angles. So let's look and see. This definitely looks like the letter V right here. What do you think about this corner over here? Does it look like the letter V? Sure does to me. And how about this last one? And you can turn your book just like I am. That also looks like the letter V. Granted, this one's a little bit wider, but again, it's still not to that L shape yet. So how many angles are letter V's? All 3 of them. And remember, a letter V means it's acute. 3 of them are acute. That's an acute triangle again. Looking at this one, if I had to give it a first name, all 3 sides are different lengths. So I would call it a scalene acute triangle. All right, we're moving over to page 917. We're going to do numbers 5, 6, 7, and 8. Let's take a look at number 5. Taking a look at this corner right here, and you can turn your book. This corner right here is definitely like the letter V, so that's acute. I'm going to just put a little A to remind myself. Let's look at this other corner. This corner right here looks like the letter V. It's acute. I'm going to label it again with a little A for acute. And this last one right here, this one actually looks like it's wider. I'm sorry. Let me look at it. It looks like it's almost 90 degrees, but not quite there. It's just a smidgen less than 90 degrees. So it is acute. So all 3 angles on this are acute. We're going to call this an acute. And I'm going to show you, you can abbreviate triangle with a little triangle, acute triangle. Number 6, let's look at it. This corner, definitely a V, so that makes that acute. This corner is also a V, acute. This corner, also a V, acute. So number 6, acute triangle. Number 7, take a look at what this means. This little box means this angle is exactly 90 degrees, which makes it right, a right angle. If you go back to your key concept chart, it only takes one right angle to make a triangle a right triangle. So as soon as we see that it has one right angle, we know it's a right triangle. And number 8, looking at this, this is very similar to the pyramid up here. It's just turned a little bit differently. This is a V. This is a V. This is a V. So they're all three V's. If they're all three V angles, acute angles, we're going to call this one an acute triangle. And you might say, Mrs. Stiefel, what does a obtuse triangle look like? And if you look up here, this is a very good example of one. Obtuse triangles are not very tall. They're kind of like flattened, almost like something had sat on them. Okay, almost like something had sat on them. All right, something heavy. All righty, boys and girls, we've got one more to do on page 918, number 11. We're looking at the sandwich again. And if I were looking at this sandwich and I could mark it, maybe I'd use a couple toothpicks, I would definitely say that this angle right here is a 90-degree angle. So if there's one 90-degree angle, it only takes one 90-degree angle, it's a right triangle. So if we were going to name this by its angles, its last name would be right, its first name would be scalene from yesterday. So over here, we would call this, its full name would be scalene right triangle. Now, don't try going to the courthouse and changing your name to scalene right. I don't think they'll let you. I don't even know that they're open. I'm just teasing you. But for this triangle, it would be a scalene right triangle. Boys and girls, I miss you a whole lot. Good job today. There is no submission of work for Thursday, May 7th, Fido Day 33. I miss you tons. Take care.